Lesson 25, Type Conversion Operators. To follow along with this lesson, you will need to create a new console project and add a new file named main.cpp to it, as we did in Lesson 1. Oftentimes we will have a value that we want to use somewhere, but it is of the wrong type. For instance, this function prints out the value of a passed in double. To print this int, the function must convert the int to a double. The same is true if we assign a double an int value. Likewise, if we add a double to an int, the int gets converted to a double before the addition occurs. In these three cases, the compiler converts the type automatically. These are called implicit type conversions. The conversion from int to double is always safe, since the double type can represent all int values. This is true because the double has a much wider range than the int. Sometimes we will find it necessary to tell the compiler to make a conversion for us. For instance, if we divide an integer with the value 1 by another integer with the value 2, the result is 0 since integers cannot represent fractions. To get the answer 1/2, we need to convert the arguments to doubles before performing the division. This requires an explicit type conversion. The syntax for an explicit type conversion is just the target type in parentheses. As long as we convert to types that have greater precision, everything works fine. However, we may want to convert an int to a char or an int to an unsigned int. Generally, as long as the value that is converted stays in the common range, the conversion will happen as expected. On the other hand, if we want to convert an int value of -1000 to a char or an unsigned int, we get a conversion that is undefined and will give unexpected results. Notice that I had to use an int type conversion on the chars so that we could see the ASCII value and not the character that it represents. This is yet another use for type conversions. Mixed type expressions, the compiler will always favor the type with the greater range. If we compare a double and an int, the compiler silently converts the int to a double and then compares the values. If we compare an int to an unsigned int, the compiler gives us a warning since neither type has greater range. To get rid of the warning, we let the compiler know that we want the values compared as ints, for example. This is potentially problematic though, and we need to be careful with our value ranges. There are a few more points to be made about type conversions. Converting ints to bools used to be common, particularly in old C code. Eventually, you will probably see that used somewhere. When converting to a bool, 0 converts to false, and everything else converts to true. This is true regardless of whether the converted type is an int, double, char, etc. Conversions from a double to an integer type are truncated at the decimal point. This means that 1.5 converts to 1 and -1.5 converts to -1. Note that this conversion is equivalent to the floor operation for numbers greater than 0 and the ceiling operation for numbers less than 0. For C++ types, we can use either an explicit type conversion or the constructor notation. These two operations are equivalent for built-in C++ types. We can also convert integer types to pointers and vice versa, but this is very dangerous and should not be attempted by novice programmers. Finally, we can convert pointer types to other pointer types. I don't recommend doing this with the type conversion operator, except in rare cases. We will develop better methods in later lessons, and I will refer to the pointer conversion as typecasting to distinguish it from type conversion. The reason for this distinction will become apparent eventually. This concludes the lesson.